Welcome back. Problem number 1676. Lowest common ancestor of a binary tree. Given the root of a binary tree and an array of three node objects, which you can refer them as nodes, we should return the lowest common ancestor, which is LCA, of all the nodes in nodes. Yeah, all the nodes in nodes, it looks quite like confusing, but yeah, it is how it is. All the nodes will exist in the tree, and all values of the tree's nodes are unique. So we have to read this as well. So extending the definition of the lowest common ancestor of a binary tree in Wikipedia, the lowest common ancestor of n nodes in the binary tree is T, where T is the lowest node that has every PL as a descendant. Okay, what that means, it looks quite not that easy to understand, and the explanation of the problem, in my opinion, is not that good. So if you are in an interview and you have like a data structure problem, it's really essential to 100% understand what is a problem all about. So if we read this problem and we don't understand what's going on, you have to, or you must, ask the interviewer to try to explain and make the problem way more simpler so you can understand exactly what are the requirements. Just remember that when you are in a data structure interview, it's not all about to solve the problem. It's you can just think about it as a peer-to-peer programming between two candidates that together they are trying to find a solution to a specific problem. So you treat your interviewer as a candidate, not like as an actual interviewer who wants to put you in bad situation and tough places. So in order to understand what is a problem, we need to find the lowest common ancestor of binary tree. So you are given a binary tree and list of nodes. We have here the list of nodes, and you need to find the lowest common ancestor of all the nodes in the list. And the lowest common ancestor of multiple nodes is the lowest node in the tree that has all given nodes as descendants, and node can be descendant of itself. Okay, let's first talk about what is a binary tree. A binary tree is a tree where each node has at most two children, referred to as left child and right child. And the lowest common ancestor, here the lowest common ancestor, it will be 4 and 7, because the lowest common ancestor of nodes 4 and 7 is 2, as you can see here. So for a set of nodes which is P1, P2, and P of n, etc., the LCA in the lowest node is a binary tree that has all the given nodes as descendants. And a node can be considered a descendant of itself. So if one of the nodes is the LCA, it should be included as well. So let's make like some sort of example definition. I guess this problem, let's make, okay, I'm opening Miro right now. Sorry. Yeah, let's try here and make this in white. Let me copy this one and let's try to create a block code. No. I need to have like, I guess there was like something like more apps. I don't know. There was like elements. Anyway. So let's say that we have a tree here. So we have 3. Let's make this quite. We have 3 as root, and we have 1, and we have 5, and let's continue with 1. We have here 8, and we have here like 0 as well. We have here 2, and we have here 6. and let's say that we have 4 and we have 7. Okay, so in this one, the binary tree should be 7 and 4, the lowest, the LCA, and the lowest common ancestor of nodes 4 and 7 is 2. This is the lowest one. There is nothing lower than that. And this is the explanation of it. And if you try to give it another example, like in terms of the binary tree and stuff, you try to find it. I'm trying to find the lowest common ancestor of 4 and 7, and it will be 2, and I will return it right away. How is this going to work? Let me see, where should we? Yeah, it will be quite simple. In my opinion, we will try to do some sort of a recursive function that will try to call itself until we find the LCA. So how we will do that? First, I need to convert the nodes array to a set for O of n lookups. So first, I will say const node set, and will equals new set. Here it will be nodes dot map, and I will say for each node return node dot value, and I would say I will create the function, and I will call the function. Let me just make this quite wider, and let me just, can I just do this? Oh no, this is not possible. But can I just put this downside so the code will be quite easier to look at? Okay, so I'll create a function here, and I'll call this function find the lowest LCA. Okay, and it will be take node as an argument, and here I will say, okay, if I'm trying to call a recursive function that will try to call itself over and over until we find the LCA. So whenever we're creating a recursive function, it's important to find the base case or the base scenario to make sure that we really not letting the recursive function to run forever. So we our computer will not get mad from this. So I'll say if not node, I will return null. Other than that, I will say there's other one here. I would just say if node set dot has node dot val, because we said that node has value here, node dot val. You have to look at this constructor, or like this is this class, function class. I would say, okay, if node dot set dot has node dot value, I will return the node. Okay, and I will try to do const left, which will equals the find LCA on the left side of the node. So I will say node dot left, because if you can see here we have node dot left and node right, and we will do the same thing for the right. So on the right here it will be node dot right, and I will say if left and right, if we can find both of them, we return node. Otherwise we return left and if that wasn't the case, let's return right. And we call this function on the first one, which will be the root, and we return whatever comes from it. And we need to describe what just did happen here. So first we convert the array of nodes to a set for faster lookups. Number two, we have the recursive LA finder. So we define a helper function called find LCA that searches for the LCA in the tree. If the current node is null, we return null. That means there is nothing to look up to. If the current node is in the set of target nodes, we return the current node because we find it. After that, we recursively search in the left and the right subtrees. If both left and right are non-null, the current node is the LCA. Otherwise, we return the null result from the left or right subtree. In this one, as you can see here, the tough thing about any recursive function, it's really not easy to understand because we're creating a function that trying to call itself, and it looks like a quite mad block of code that is not easy to be understand. So if you look at this one, let's just take this as example. So you will call it you will call the find LCA on the root, and after that you call it on the right side and the left side. And actually there is a left and there is a right, and after that we find the recursive function. We'll take 5 and 1 and we call it again on the left side, on the right side, and we'll start doing this until we reach number 2. So we have the left side and the right side, which is 7 and 4, and we return the node which will be number 2. I would say that whenever you are working with a recursive function that are trying to call itself over and over, you have to give yourself like a time and also a break, because it's not that easy to understand any problem that will be solvable with a recursive function. I did tons of problems in recursive, and after all of this amount of time and all of this problems that I did solve, I still struggle with recursive functions or recursive based data structure questions. So it's not that easy to understand. So this approach ensures that we effectively find the lowest common ancestor for the given set of nodes in the binary tree. And that's it for this one, and see you in the future. But let me submit this first to make sure if it works. It works, and we're operating 90%. And I would say that the trick here is to just to make sure that you put the nodes in the set to make sure we have O of 1 lookups. It will be way more easier or way more better than O of n lookups for normal arrays. So that's it for this video, and see you in the future.